Hello everyone, welcome back to 15th session of this IoT course. Last session I have demonstrated that how you can connect Cloud for RPI with Raspberry Pi and sensors. Now I will show you how to build IoT application by using ThingSpeak cloud services, Raspberry Pi and sensors. Agenda of this session: introduction to ThingSpeak cloud services, and also I will discuss how you can configure the ThingSpeak, then configuring IFTTT for getting SMS alert or email alert, then integration of ThingSpeak with Raspberry Pi and sensors. So now I will state what is ThingSpeak, or you can say what is ThingSpeak IoT platform. First is what we can do by using ThingSpeak Analytics IoT platform. Collect data from sensors, that is things. Visualize data instantly, has more than 60,000 users. Analyze data. MATLAB integration allows users to run scheduled code on data coming into ThingSpeak. Act on data. For example, send a tweet when the temperature in your backyard reaches 32 degrees. For example, that means you can also create alert or you can tweet. That means you can set the alarm. This is the picture of how it is working. That is, you can see guys, that you can send the data to the cloud, that is ThingSpeak cloud, and in this ThingSpeak cloud analytics can be done, and the data is coming from the sensors, or you can see the microcontroller board or computer. So now guys, I will show you how you can register in this ThingSpeak. So who uses ThingSpeak? Makers, academics, engineers and scientists. This is the website, guys, thingspeak.com. Just go to this thingspeak.com and register. First, what we have to do? First, we have to click on this link, or just type this link, that is thingspeak.com, in your browser URL bar, and then this screen will come, and just click on this button already highlighted over here. You can see guys in the picture. To create new account, click here. So now we will give your email, the valid email address. It is not necessary you have to give your organization email address. You can also give your personal email address. Then after that, so they will send you one email to your account. You have to verify this email, and then you have to fill up all these things, that is some credentials like email address, your location, first name, last name, and all these things. Then you have to press the continue button. This is the screen, that is the email verification screen. So now you have to set your password, and after setting your password, you just log into the account. That is, you have created one channel in this particular ThingSpeak, right? So just click on new channel, creating the channel. That means after that, after entering the password, that means we have created one account in ThingSpeak. Now we'll get this screen and click on new channel. After that, you will get this one. So we are actually implementing temperature and humidity monitoring of a room. So that is why. So first give a channel name. You can see guys the name field. Then you can give any description of the channel. Then there is a field 1 and field 2. So in field 1 you give temperature, and field 2 you give humidity, right? Then just only save it. After that, we just click on save. Just go down and save. So after that, we will get this screen.
Guys, you can see the screen.
So here you can see the temperature and the humidity value in a graphical fashion. Now you go to API key tab and click on this tab. You will get this screen. This is the API key. You have to copy this API key and you have to paste it in your code, by which you can connect the Node MCU and the ThingSpeak cloud. This write API key helps to identify your channel. One. So now I'll show you guys how to create an account in ThingSpeak and how to create a channel in ThingSpeak. Type thingspeak.com in your browser URL bar, then enter. Click on sign in, but you are not existing user, that's why you have to click on create one. Then give your email address. My case is madri2021l@gmail.com. Then select location. My case is India. Then give first name and last name. Then continue. Then you have to select this checkbox. Use this email for my MathWorks account, and then continue. As soon as you press on continue, you will receive an email. So guys, you can see this is the verification email. Click on that and click on this verify email. As soon as click on this, you will get this screen. Your profile was verified. Now go to once again this screen and continue. And now you can set your password. I think you can see guys, this is fair password. Okay, so that's why you have to accept this service agreement and then continue. And then your sign up successful. Click on OK. So that's it. So this one, how are you planning to use ThingSpeak? So I think it is for our testing. So you can click on student use, or for my case is teaching. Okay. So I think guys, you can see this is the kind of a dashboard, right? So say here there is a button called new channel. Now you can click on that to create a new channel. So what is our project? Temperature and humidity monitoring in a room. So that's why you have to give a name relevant to that. So you can write over here temp and humidity monitoring. Or you can give any name, whatever you want. So here you can write, we are using DST11, that's why you can write DST11 over here. But as per your requirement, you write the description about the project. So I am writing only DST11. So now you select the field. So in our case, first field is the temperature, second field is the humidity, select this one. Next is humidity. Okay. So now just go down and then just click on save channel. As soon as click on save channel, you will get this channel dashboard. So where we have the channel ID, then you can see different tabs: private view to display the data, public view to display the data, and channel settings, sharing, API keys. So we need this API key, right API. Click on that, because when I want to communicate with this Raspberry Pi and this ThingSpeak, I need this one, because by which Raspberry Pi can identify this channel. Okay. I'll show you all the things when actually I'll start communicating with this Raspberry Pi and ThingSpeak, guys. So that is the way we can create the channel. Also, you can share this data or the link, whatever you want. I have configured ThingSpeak successfully. Now I'll tell you how to configure IFTTT Applet. IFTTT is a web service that lets you create applets that act in response to another action. You can use the IFTTT webhooks service to use web request to trigger an action. The incoming actions is an HTTP request to the web server, and the outgoing action is an email message. That means if you want to get SMS alert for a particular action like temperature rise or humidity rise, whatever be the cases, so you have to use IFTTT with ThingSpeak. Analyze channel data to send email notification from IFTTT. The analytical power of ThingSpeak and MATLAB allow you to generate filtered, targeted, and specific notifications of channel activity. The external web service IFTTT lets you turn the ThingSpeak notifications into email and text messages. So guys, you can see the interface of IFTTT. Click on sign up for new registration. Click on create. Click on this. Search for webhooks and then click on webhooks. Click on receive a web request. That means choose your trigger. Type your event name. So in this case, this temperature and humidity. Then click on trigger. Guys, you can see this is the webhook option. If webhook, then plus that. So click on that. Choose action service. In my case, it is email. Type email and click on email. That is search email and click on email. So then confirm your email address. Just type your email and you will receive a pin in your email address, and type this one, in this case 7837, and connect. Click on send me an email. Please choose action. Then complete action fields. So we can type any subject of email or the body of your email. Then create action. Then the review your entire request. So what you will receive, when you will receive. So this is the review. If you are satisfied, just click on finish. Applet is created. Guys, you can see from the page. Now go to explore and search webhooks. Click on it. Guys, you can see that post or get web request to this URL. So in this URL there is event. So you have to type your event name. That event name was temperature and humidity. Just type it over here. Then test it. That means click on test it. Guys, this is the URL, and now you just copy this URL. Go to ThingSpeak. Click on app. Click on ThingHTTP. Then click on new ThingHTTP. So now you can change the name of request, right? Then paste this URL in this URL box, and you can type anything in the body, but this is optional. Go to app once more, click on React, then click on new React. You will get this screen. So now the condition type should be numeric. Change it to numeric. Then select the field and just set the condition. That means whether the temperature is, in this case the field is temperature. So whether if the temperature is greater than 20 degree or 60 degree, so we will receive email. So in this case it is written 60 degree. That means if temperature is greater than 60 degree, you will receive an email. So then once again choose ThingHTTP. Then type the request name over here. Then choose the run action each time condition is met. Guys, you can see this is the email you will receive. Okay, so now I will go to IFTTT and configure. Go to browser and type IFTTT. Click on this. Guys, you can see the screen. There is the interface of IFTTT. Click on create. Click on this. Search for webhook. Click on webhook. Click on receive a web request. Connect. Click on connect. Type event name. Click on create trigger. Click on that. Search for your service, that is email. Click on email. Click on send me an email. Click on connect. So you have to give one email address where you will receive the pin, guys. Please wait. So guys, you can see this is the pin. Copy it and paste it over here. I'm typing over here. Connect. So this is the subject of your email and the body, so you can accordingly configure. So I'll just clicking on create action. So then continue. Guys, you can see this is the event name, this temperature underscore rise. So this is the actual applet title. Then click on finish. So I think you will receive email, the alert email in this email address himadri2021l@gmail.com. Go to explore, search webhook. Click on webhooks. Go to documentation. Guys, you can see the URL. So that is post or get web request. So I'll type the event name, that is temperature underscore rise. Now test it. Please wait. Event has been triggered. So now copy this one. So now go to ThingSpeak. So just already it is signed in. So just that's why click on app. Click on ThingHTTP. Then click on new ThingHTTP. So just change the name as so given the name temperature underscore rise, you can give whatever name you want. Then I am copying this URL which I have taken from IFTTT. Just I copied it. So no need to write body, but this is option. I can write any body whatever you want. Save ThingHTTP. Okay, done. So now go to app once more. Go to React. Click on new React. So now convert this condition type to numeric because we are receiving numeric data. So now field is one is temperature, and you have to set the condition is greater than 20 degree. The temperature greater than 20 degree, then you will receive email, alert email. So select the action ThingHTTP, and so then you have to select the temperature rise. This is the name, right? I have given. So then you click on the second option, that is run action each time condition is met. Okay. So then click on save this React. Okay. So it is over. So guys, I will go to presentation now. So this is the project I will demonstrate, that is automatic air temperature optimizer using temperature sensor. Problem statement: temperature control is an important part of many industrial processes. Raspberry Pi allows us to automate this process with ease. Here we use our DHT11 module to track temperature and humidity to keep track of the environment it is in. You can add a temperature controller to the Raspberry Pi which releases coolant when there is a high temperature. This is the circuit diagram. This is the DHT11 sensor and the Raspberry Pi. Already I told you DHT11 sensor has 3 pins. First one is the VCC which is connected to 5 volt. The middle one is the data pin which is connected to GPIO pin number 4, and the last one, the black one, is ground pin which is connected to ground pin of Raspberry Pi. Now I will discuss different components of Raspberry Pi. This is Raspberry Pi 3B plus. I'll open the case. This is Broadcom processor. This is Wi-Fi and Bluetooth module. There are 4 USB ports for connecting your keyboard, mouse. This is Ethernet port for connecting Ethernet cable to get the internet through Ethernet. This is audio port where you can connect your headphone and microphone or speaker. This is Pi camera slot where you can connect your Pi camera. This is HDMI port through which you can connect your LCD display or monitor or TV, whatever you want. Guys, I'll show you the SD card. This is the SD card. In this SD card, you have to install the Raspberry Pi OS. After installation, guys, you can see here, you can insert it into this SD card slot. That's it. This is micro USB type B port through which you can connect this wire, and now you can connect this wire to your laptop for getting power. This is LCD display slot. You can connect small LCD over here. But this is the port through which you can connect your LCD TV or monitor, all these things. But point to be noted, this is HDMI port. If you have VGA port in your monitor or TV, you have to use one adapter to convert VGA to HDMI. Then only you can connect to this port. There are 40 GPIO pins over here. Each of the pin having different functionalities. For example, ground pin, VCC pin, or you can say these are the pins, the GPIO pins, which can be connected to your device or the sensors according to your requirement. This is the blue one, is called the printed circuit board. So already I told you this is the type B cable. The one part is connected to this Raspberry Pi, another part is connected to the laptop or your computer, whatever you want. Now I'll assemble all these components for this project. This is Raspberry Pi. Already I have discussed about that. This is DST11 sensor which has 3 pins. A positive, there is red one, will be connected to 5 volt of Raspberry Pi. The middle one, that is data pin, will be connected to GPIO pin number 4 of Raspberry Pi, and the negative, that is ground, will be connected to ground pin of Raspberry Pi. Now I will connect this sensor to this Raspberry Pi. First I will connect this pin, that is positive pin, to Raspberry. So connected. So now I'll connect the ground pin to this one. So now I'll connect the data pin to this GPIO pin number 4. Now I'll connect my micro USB type B to this Raspberry Pi and to my laptop. As you can see, the power is on. So now I will tell you how to install DHT11 library or Adafruit library. Guys, you can see the commands already I have discussed earlier. So now this is the code. So you have to copy paste the right API key over here in this code. This is my API. So guys, you can see Adafruit underscore DST dot read underscore retry. So that will have two parameters. One is the DST11 sensor type and another one is the data pin number, that is 4. So this function will read the data from the sensor and store it to RS, that is the humidity variable, and T is the temperature variable, and return humidity and the temperature after converting into the string to the calling function. So guys, you can see I have written one function, the def get sensor data, that will return temperature and the humidity value but in the form of string. So now guys, you can see the main function. So you have to give the API key from the command prompt when you are executing the program. Okay. And this is the base URL we have, and guys, you can see there is a while loop where actually we are taking data from the sensor, get sensor data, and it will be uploaded into this ThingSpeak by URL leave 2 dot URL open, then base URL plus the parameters, that is field 1 and field 2, that is humidity and temperature. You can also print f dot read function. So guys, this is the visualization screen. Actually, you can see two graphs in ThingSpeak, in private view or public view, temperature and the humidity. Now I will open advanced IP scanner. Click on scan. As you have seen, I have connected Raspberry Pi and ultrasound sensor to my laptop. Okay, so as you can see, this is 192.168.0.12, that is blue, that is active. So I'll copy this IP. Minimize. Click on remote desktop. Then copy. Then connect. Yes. Give username is 5 and password is raspberry. This is my Raspberry Pi interface, guys. Let's go to terminal. This is the code, already I have explained, guys. As you can see over here, the same code already I have discussed. This is the adafruit underscore dst dot read underscore retry. It is taking two parameters on the dst level, sensor type and the data pin number. And I have written one function called get sensor data. So it is called over here. You can see in the main function. Here we have this while loop. Okay guys, so now I'll show you that how you can execute this program, and also I'll show you that if the temperature rises, whether you receive any alert from IFTTT or not. So I'll go to terminal, because already I told you that you have to give your API key of this channel. So that is my API key, guys. You can see this is the Python code and this is the file name. Just you enter. So guys, you can see it's starting. That means ThingSpeak will receive data now. Go to ThingSpeak once more. Okay, so go to channel, click on my channel, click on DST11 sensor, go to private view. So guys, you can see this is the last entry less than a minute ago. So that's why I click on that. 15 July. It is just a minute, and I'll show you the exact timing. This is 16:55. Yes. So the temperature is 27 degree, and just a minute, I'll show you the exact 16:56 the timing. So you'll be receiving humidity as 31 degree. Okay. Sorry, you'll receive humidity as 31, that is percentage in percentage. So that is the thing. So now we can download the your data from here. Click on data import export, click on download. So then as you can see, open it. So as you can see the Excel file or CSV file. So you can use this file for analysis, or you can directly import it from ThingSpeak in any machine learning platform like Google Colab. Maybe private view or public view. So if it is public data, then it is public view. You can change the setting to public view. This is the channel setting, right? Okay, and then you can also share this thing to your friends. And this is already I told you, this is the API key we are using. So now I'll go to my email address and check whether we will receive any alert or not. Yes, guys, you can see the email. So the temperature rise actually my event. So I've received many emails because the temperature is 27 degree temperature, because I've said that if it's greater than 20 degree, then I will receive this one. Okay, guys. Okay, this is the all about the air temperature control or monitoring project. So I'll come to presentation once more, and then we must do the second project also, guys. Now I'll come to the second project, that is anti-collision system using ultrasound sensor problem statement. We can monitor the position of an object remotely. If the object is too close to an obstacle, we can change its direction. Such modules can be inserted in drones for remote surveillance. In this project, we connect the ultrasound module to the ThingSpeak cloud. You can control the movement of your object through the cloud by adding motors to it. So this is the circuit diagram. This is the ultrasound sensor and the Raspberry Pi. I told you ultrasound sensor has 4 pins. The number 1 is VCC, which is connected to 5 volt. Number 2 is trigger, which is connected to GPIO port number 21. Then you have echo. Echo is connected to GPIO port number 20, and lastly you have ground. Ground is connected to the ground pin of Raspberry Pi. So already I told you that trigger is used to generate the sound wave, or you can pulse, and it will bounce back and echo will receive it. Then you have to calculate the duration, that is the sending signal time and the receiving signal time. Then you have to convert this duration into the distance by using some standard formula. Now I will discuss different components of Raspberry Pi. This is Raspberry Pi 3B Plus. I'll open the case. This is Broadcom processor. This is Wi-Fi and Bluetooth module. There are 4 USB ports for connecting your keyboard, mouse. This is Ethernet port for connecting Ethernet cable to get the internet through Ethernet. This is audio port where you can connect your headphone and microphone or speaker. This is Pi camera slot where you can connect your Pi camera. This is HDMI port through which you can connect your LCD display or monitor or TV, whatever you want. Guys, I'll show you the SD card. This is the SD card. In this SD card, you have to install the Raspberry Pi OS. After installation, guys, you can see here, you can insert it into this SD card slot. That's it. This is micro USB type B port through which you can connect this wire, and now you can connect this wire to your laptop for getting power. This is LCD display slot. You can connect small LCD over here. But this is the port through which you can connect your LCD TV or monitor, all these things. But point to be noted, this is HDMI port. If you have VGA port in your monitor or TV, you have to use one adapter to convert VGA to HDMI. Then only you can connect to this port. There are 40 GPIO pins over here. Each of the pin having different functionalities. For example, ground pin, VCC pin, or you can say these are the pins, the GPIO pins, which can be connected to your device or the sensors according to your requirement. This is the blue one, is called the printed circuit board. So already I told you this is the type B cable. The one part is connected to this Raspberry Pi, another part is connected to the laptop or your computer, whatever you want. Now I will assemble the hardware for this project. This is Raspberry Pi, already I told you, which has 40 GPIO pins. This is ultrasound sensor, already I told you there are 4 pins. One is called VCC, another one is ground, another one is trigger, another one is echo. So now I will connect this ultrasound sensor to this Raspberry Pi. So first I will connect VCC to 5 volt. Now I'll connect trigger pin to pin number 18. Then I'll connect ground pin to ground port. Then I'll connect echo pin number 24 for this project. So I'll repeat once more. I have connected VCC in 5 volt port, ground in ground port, and trigger in port number 18, GPIO port number 18, and echo in port number 24. That's it. Now I will connect micro USB type B cable to this Raspberry Pi and to my laptop. So this is the code once again. This is the API key, guys. You can see you have to copy paste the API key. Already I told you trigger pin and the echo pin. So the trigger pin should be the output pin because it will generate the signal, and the echo will be the input pin because it will receive the signal. Guys, you can see in GPIO setup, that is trigger is output pin and the echo is input pin, and the trigger pin number is 18 over here because in my implementation I use 18. So and this is echo pin is 24, and this is the base URL. Why we have to add the my API key, that's the right API key. Guys, this is the function called distance. So the trigger will generate the signal, guys. So you can see trigger is true and then false, okay, and echo will receive 0. Then you have to calculate the start time, and when it will receive 1, and then you have to calculate the stop time, and then you have to find out the elapsed time, subtracting start time from stop time, and then you have to convert into the distance by using standard formula. Then you have to return the distance. In the main function, there is a while loop. So actually distance function is called, and you're printing the distance value, and then this is the connection URL, right? So you can publish the data into this ThingSpeak cloud by this one. So this is the display, that is the visualization. You can see the graph of ultrasound resistance in ThingSpeak. Now I'll open advanced IP scanner. Click on scan. As you have seen, I have connected Raspberry Pi and ultrasound sensor to my laptop. Okay, so as you can see, this is 192.168.0.12, that is blue, that is active. So I will copy this IP. Minimize. Click on remote desktop. Then copy. Then connect. Yes. Give username is 5 and password is raspberry. This is my Raspberry Pi interface, guys. Click on my folder Pi and also I'll close this window, go to Pi and click on email underscore ThingSpeak file. Guys, already I have discussed this code to you. Just click on learn. As you can see, distance and the number means it's receiving the data, sending the acknowledgement. So I'll go to ThingSpeak now. So I'll go to channels, go to my channel, go to ultrasound. Guys, you can see, click on private view. Guys, you can see this is the less than a minute ago, right? So last entry, so click on that. So guys, you can see this is the distance value and the time is 17:02. Okay, this is current one and the date also 15. Okay, so now if you want to download the Excel file, the CSV file for analysis, just click on that. So this is the data value. So you can directly take this from this ThingSpeak by using some API for analysis in any machine learning platform for analysis. You can share it also, guys, from here. So channel settings, you can set it. Already you have done this one, and you can make it public also. Okay, so this is more or less all about your project. So guys, I just want to show you one more thing to you. So now car is very close to this sensor. So now you can see, guys. So if you just, as you can see here, distance is changing, but now it is increases to 19 because the car is going far from the sensor. That's it for today. Thank you very much.